Okay, guys, so welcome to part 2 of the series. We're looking at exercise 1, level 2. Alrighty, so that we're on page 3, and let's finish level 2 now. Now, the first question is asking find the value of k so that the angle between the vector u and vector v is 45 degrees. So, as always, let's construct a vector diagram. Our x and y axes, and now let's put vector u, which is at 1 and negative 2. So vector u is somewhere there, okay, with 1 and minus 2 as vector u, okay. And vector v, let's say it's a dot because it's at 2 comma k, and we do not know the k, so the k can be positive, so it can be upwards, or it can be negative, downwards, okay. But it doesn't matter. This is an arbitrary, that's why it's a dotted line. We do not know where it is. And they give us that this angle between vector u and vector v is 45 degrees. Yeah, that was not visible. They're telling us that this is 45 degrees. And this is quite nice because it helps a lot. Now, what we're going to do is we know that the dot product of two vectors is a scalar. Let's try getting something. Let's go from there. Vector vu times vector v is, we know, equal to the magnitude of vector u times magnitude of vector v. Let me draw u properly. Times magnitude of vector v cosine theta. Because if the vectors are acting in perpendicular direction, we do not need to take in consideration of the theta. But then, because this is not and this is at an angle, we do need to take into consideration the theta. So this is a general form that you just always use when you're dot producting something. That's what you need to be looking at. Already? Oh, cool. Now, they're telling us that, okay, what we want to do is first figure out what information we have. Do we know the dot product of vector u times vector v? That's why we're going to go to the side and we're going to do our red table thingy. So the dot product of vector u times vector v is equal to multiply the x plus the minus plus the y components. So the plus is 2 minus 2k. Okay, that is our dot product. What's the magnitude of vector u and the magnitude of vector v? Okay, the magnitude of vector u is just the square root of 1 plus 2 squared, like negative 2, but the sign doesn't really matter. So that's just 4 plus 1, which is 5. So it's square root 5. And this one is just square root of 2 squared plus k squared, which is square root of 4 plus k. K squared, my bad. And, well, you can put this in a star. Okay, and move the star to the end. We can refer to information from the star as we're working through. So let's just sub in the information we know. We know that u dot v is 2 minus 2k. Let's sub that in here. 2 minus 2k is equal to what's the magnitude of vector u? As you can see here, it's root 5 and vector v is this. So 4 plus k squared, and then cos of 45 degrees, because they give us theta is equal to 45. Simple. Now that we have this done, this is all you need to do. If you've come this far, well done. You understand how vectors work. You understand the theory of behind vectors. Now it's just algebra work, because we want to find k, so we can square both sides to get rid of the square roots here. So 2 minus 2k whole squared is equal to 5 plus 4 plus k squared cos 45. Right? What's cos 45? It's let's check again. It's root 2 on 2, so 1 on root 2. So, oh, but yeah, the cos 45 also gets squared. So when you square this, it's just going to be 1 on 2. Okay, so this is just equal to phi on 2 4 plus k squared. Okay, clear? That squared is equal to that. So then, oh wait, this is a wrong way of doing it, because we're supposed to like, what was wrong about this step is that, guys, I've put the square here. So I need this exact term. I need to square the exact term. I cannot go ahead and simplify the next step on the same line. So what we got to do is we got to rewrite this, but with the square around it, so they know what we're doing. Okay, then we can go on with this step, which is equal to, what's 2 squared? 4. What's this? Sorry, 4k minus 8k plus 4k squared. Okay, now we can take the 2 to the other side, so that's just equal to 8 minus 16k plus 8k squared is equal to, what's 5 times 4? 20 plus, this is, remember, k squared. So 5 times k squared is 5k squared. Easy. So now let's just bring it all to one side and let it equal to 0. So 8 minus 20 is minus 12. And 8k squared minus 5k squared is 3k squared. So 3k squared minus, we have the minus 12, but there's the minus 16k minus 12 is equal to 0. Okay? Yeah, easy. Now this is just a quadratic that you can solve. So you can apply the, what do you call, minus b plus minus square root of 4a squared, no, b squared minus 4ac. So what, this is minus, so using quadratic formula, okay, just do this and the answer that you should get when you do this is k is equal to 6. Is that k is equal to 6 or k is equal to minus 2 on 3. Easy. Now, this is not your final solution because there's only one value of k that can satisfy this. And there are multiple ways that you can go on about checking this, but the easiest and the smartest way to do it is, see this 2 minus 2k? This has to be greater than 0. Righty? Why? Well, I don't know yet, but this has to be greater than 0. So then k has to be less than 1 by that logic. So in our two options, the only value for k is less than 1 is this value. Therefore, our k is equal to minus 2 or 3. If we do actually understand why it is that we need to take the 2 minus 2k as greater than 0, why should the dot product be greater than 0? Is that a rule or something? Should the dot product of two vectors always be greater than 0? Let's check. Should the dot product of two vectors always be above 0? Let's ask AI. Because I don't know, guys. The dot product of two vectors, yes. Okay. Yeah, okay. I have no clue why we take that as 0, but to get the answer, you do need to do that. Okay? And that's your answer there. Now that you know how to do question B, question A, I'm not going to walk you through question B. I said I'll solve it with you guys, but I'm not going to be systematically speaking it out with you guys as I just did. So let's go speedrun B. Step 1, vector diagram. Step 2, add in the information. U is equal to k3, this is equal to 2k. Okay, what I understand now is that the vector diagram is actually not going to help you because we have two unknowns. We actually do not know where it is. If you want, you can just draw it in for reference. Okay, so k can be positive or negative. So let's take this to be k. Okay, and v is 2k. 1, 2. Okay. Let this be a u and let this be a v, and this angle is 60 degrees. Okay, easy. That angle is 60 degrees. That's a diagram if you wanted a diagram, but I wouldn't advise doing a diagram for this question because it doesn't really help. So what you first want to be doing is you just want to get started into the dot product. So let's write our yellow tips here. So what's a dot product? U vector u dot with v is equal to easy so easy, we got our red box. Now let's just find the value of k so that the angle between u and okay. Now we have the information. Let's go put this into this formula. Just don't want to write it again. That's all. I'm lazy. Let this be here in the side. Okay, easy. So u dot v 2k plus 3k. This is just sub. Oh, also I forgot to say, from this line, right? You really want to say in this line where you subbed in, the magnitude of u, v, and u dot v. You want to say from the star. You want to address the star because you want to address that you got the information, you did the calculations in the star because you want them to know everything. They want to know everything. Also, they're going to be like, oh, what did you do? Did you cheat from the next guy? Just be safe, guys. Easy. Now just square both sides. Now this is expand. 4k squared Let's cos 60. And let's take the 4 over to the other side. This is really inefficient. We can just combine this and multiply by 4 once. Let's combine this now. Let's expand. 9 times 4. And let's take it all over to the, let's take all this over to the other side. So it's just this, but minus. So, hey, what's this? Oh, this is 4k squared. Combine both these here, so it's 13. What's 100 minus 13? 87. 87k squared minus k4 minus 36 is equal to 0. We can then let u is equal to k squared. Okay. We can actually take the minus out. So k to the 4 minus 87k squared plus 36 is equal to 0 already. And then let u is equal to k to the 4. Then k is equal to square root of u. Right? Does that make sense? Yeah. Because that's just saying u is equal to k squared. Then we just go that we use a quadratic formula here, because this just becomes u squared minus 87u plus 36. And when you do use the quadratic formula on this, it's minus b plus minus. So minus b is 87 square root of, what's b squared? So what's 87 squared? So you don't need to write all this. You can just write 15 root 33 over 2a, which is just 2. Okay, but what I want you guys to remember is that I want to make something really important here. See how we let u is equal to k, my bad, not k to the 4, I made a mistake there, k squared. Yeah, then you can just, as if you wanted k, which is what we want in our question, right? We want k, u is equal to k squared. So k is just equal to the square root of u. So this k is equal to this. This is k squared. Therefore k is just equal to the square root. K, this is equal to u. U, which is equal to k squared, right? So then k is just equal to this, but you put this inside. Easy. That's your answer. So very little vector knowledge really, or just theory, algebra. Yeah. Okay. For non-zero vectors u and vector v, find the condition for which the dot product u times v is equal to u parallel magnitude of u times magnitude of v. Okay, this happens when we're just saying when the dot product, right, is such that you don't need to take into consideration the cosine of theta, because you know here all we've been defining that dot product of u times the dot product of v vectors is equal to the magnitude of vector u times the magnitude of v. Remember, this double line, they can use this double line and the single line interchangeably for magnitude. Just keep that in mind. But let me just show you something real quick. When we go here, right, and you go up ahead, when we dot producted two vectors, why did we not take into consideration the magnitude? Because this is vector u times vector v. Why did we not take into consideration theta at all? let me tell you why. It's because vector u is equal to lambda of vector v. All this is saying is that they must be parallel, because when they're parallel, like this and like this, they're acting on the same angle. Therefore, you do not need to take into consideration the theta. So this is just saying vector u is equal to vector v, but just enlarged by a factor, by a scalar, delta. And this delta should be greater than 0. Okay, easy. I will let you guys solve B. Not hard, but interesting, really. But